In this video, Arduino library will be created for digital complex sound generator SN76489 IC. The library has functions to enable the IC to play tones at different frequencies and also play RTTTL tunes. In my previous tutorials, I demonstrated how to program SN76489 to play different tones and to play RTTTL tunes. A link to these tutorials are available at the video description. The Arduino library structure for the complex sound generator is shown in this diagram. The name of the library is SN76489, and here we are declaring object play to constructor, and the object has arguments which indicate the connection of the data lines from the sound generator to the digital pins of the Arduino. So D0 is connected to 2, D1 is connected to 3, D7 is connected to 9, and the right enable is connected to pin 13. The library has 5 public functions. Function mute channels will mute the 4 channels of the sound generator, channels 1, 2, 3, and 4, 4 being the noise channel. Function tone will play the tone at either channel 1, 2, or 3 with a frequency designated by the second argument. Function noise will either play periodic noise or white noise based on the value of the first argument. The second argument determines the shift rate. For 0, for example, the value is n over 512, n being the frequency of the external clock 4 MHz. Function fade will fade the tone at either channel 1, 2, or 3 based on the value of the first argument, and the second argument gives us the speed of this fade. Finally, this function will play an RTTTL tune based on the string value of the argument. Now we look at the library header file where we have this class defined, which has these public members. We have the constructor, and we have the 5 methods which are defined inside the source file, and we have these private members, the declaration of these global variables, and also we have this method which is private to the class. Now we look at the source file, which has the definition of all of the members of the class. So first we need to include the header file we have just created. Next we look at the constructor, and this is the header of the definition, and here we are using the pin mode function in order to determine that the data lines of the sound generator are connected to output pins of the Arduino. Now we look at the definition of the public methods. We have method mute channels, which will mute all of the 4 channels of the device. So this would mute channel 1, channel 2, channel 3, and the noise channel. Method tone has 2 arguments. The first argument is the channel at which we want to play the tone, and the second argument is the frequency of the tone. Inside method tone, we first calculate the 10-bit tone frequency, and then using this switch statement we will send the first byte to either channel 1 or channel 2 or channel 3. Then we send the second byte. Method noise has 2 arguments. The first argument is the noise type. Either we have periodic noise or we have white noise. And the second argument is the shift rate. So if we have periodic noise, then we play periodic noise with maximum volume. Otherwise we play white noise at maximum volume. Method fade has 2 arguments. The first is the channel at which we want to fade the tone, and the second argument is the speed of fading. And here, using this for loop, we can apply the fading on the selected channel. The circuit diagram shows the interfacing of the SN76489 with the Arduino Nano. So we have the data lines D0 to D7 from the sound generator are connected to digital pin D2 to D9. And we have the write enable from the sound generator connected to D13. After we install the library within the Arduino IDE, we can now have a look at some of the example sketches. We begin with this demo sketch, which plays different tones at different channels of the SN76489. We first include the created library, and then we declare the object play to the constructor and indicate to which digital pins the data lines of the device are connected. And within the setup function, we will mute all of the channels of the device. Within the loop function, and using this for loop, we will play a tone starting frequency of 122 Hz up to 1 kHz at channel 1. And at the same time, we will play a channel to a fixed frequency of 122 Hz, and on channel 3 a tone at frequency 500 Hz. Then we will fade the audio at channel 1, and then channel 2, and then channel 3. This method, which reads and plays RTTTL string of a ringtone, was thankfully recommended to me by viewer LeFouve. The method will receive the string value of the RTTTL ringtone, and then it will begin to extract the default values from this string, and the default values would be the duration, octave, and the beats. And then the method will extract each musical note from the string and then compute the tone frequency in Hertz. And then it will compute the 10-bit frequency from this tone frequency and then send it to the SN76489 to be played. In this example sketch, which is included in the library, we'll play an RTTTL ringtone using the SN76489 sound generator. First we include our library, and then we declare the object, and then we declare this string which will store the string constant of the RTTTL ringtone. The string constant will have the name, the default value, and the musical notes for the ringtone, and the example here is the theme Axel Foley from Beverly Hills Cop. Inside the loop function, this function via the object will play the Axel Foley ringtone. The 4 channels will then be muted, and the process is repeated continuously. In this next example, we have 3 ringtones that will play one after the other. So we first play the Axel Foley theme, and then the movie Halloween, and then the Muppet Show. In a future video, more functionalities will be added to the created library. Thank you for watching.